Gang. And there we go. So obviously we have a smaller room. So as we start to present this stuff, if you have questions in the middle of it, please just jump in, because with a room this size, it doesn't make any sense if you have questions to kind of wait till the end and do something kind of formal. I'm Wes Oliver. I teach at Duquesne Law School. Kate Norton teaches in the clinic at the law school as well, and she also teaches family law as part of our doctrinal classes. And so to give you a little quick intro to us, this is a lovely thing that Kate did with one of the generative AI devices that draws images. And so she programs into this one to try to capture both of us. For me, she does computer programming for law students. For her is access to justice with computer programming. Apparently, the first 8 or 9 times she tried to do it with me, I come up with a woman in a lab coat. And she kept doing it until she got a man, and that's apparently supposed to be me, or at least a representation of what I do. And then this is her clinic. Actually, I think her clinic kind of captures what I think it would. I think that's actually a pretty good visualization of what we hope the clinic looks like as we start to build stuff out there. But by way of actually introducing who I am, and I'll let Kate tell you more about her story as well. I think a really important thing is, like, how'd you get into this, right? How did someone who was a law professor for years and had no background in math or computer science at all? I was a history major and in college, and then went to law school. And like most of my work was on criminal law, criminal procedure, and legal history. And for me, for years, I would teach criminal procedure. And every year I would get to the point in the class where I would teach reasonable suspicion and probable cause. And I would say, look, folks, I can't tell you what this is. I have no idea what the actual answer is. All I can do is give you the legal standard and give you some examples of things that are more or less suspicious. And you're going to have to just sort of use your lawyerly ability to argue one way or the other. There is no good way to determine the answer to this. And I know a lot of legal standards are not determinative. But this one always struck me as particularly problematic, that it wasn't. And so one night I'm watching 60 Minutes about 7 years ago or so. And they do a story on how AI was being used to read medical journals and examine how, like, one aspect of one strain of research in one type of medical journal might actually show us something about another type of disease or treatment that's being considered, and that AI could find these lines of research that were complementary and could actually help cure things that no human could do, because no human could read all the medical journals that are out there. And I began to think, that's probable cause, right? What is probable cause? It's like the sum total of all these cases out there in a variety of contexts, all of which shed some light on what's sufficient for suspicion. And so I started talking to computer scientists, and I said, is it possible to actually come up with something that would use AI or AI-like things to figure out whether reasonable suspicion and probable cause have been satisfied? So I met with this guy, Kevin Ashley, who teaches at the University of Pittsburgh. I knew he was kind of famous in this area. I didn't know how famous, but we have lunch, and remarkably, like, I was just a punk kid who didn't know. I mean, I was a law professor, but I didn't know anything about his world. And I said, this thing you've been doing for years, I think we could apply it to what we're doing. And he said, I think you might be right, but we need to scale it down to something more manageable than probable cause for every potential crime. Is there some discrete, smaller aspect of probable cause that would occur in a lot of examples? I said, absolutely, there is. Reasonable suspicion in drug interdiction stops, the lesser standard of probable cause, that in a drug interdiction stop allows the officer to hold a car until a drug dog can arrive and do a sniff. And the way this works is, the officer pulls someone over for speeding or something, and at that point looks around in the car, sees things that might be suspicious, and if it's enough, they'll hold the car until a drug dog can come and sniff for the presence of drugs. There are these cases happen every day. I was a criminal defense lawyer, and I kind of specialized in drug work, and these were, I saw a whole bunch of these cases over and over and over again. You get the same set of facts, and also you almost have to get the same set of facts, right? because you're pulling someone over by the side of the highway. You've got 2 or 3 minutes to look in the car. Only so many different things can happen in a car in 2 or 3 minutes. There are only so many different possibilities of things that could be in there. And so we started designing this system, and it was great fun, but I didn't know what he was doing. I didn't know what he was describing and how he was going about doing the work he was doing. And I also wanted it to go faster than someone who didn't have the same commitment to this project had. So I said, I need to learn this stuff as well. So I started learning how to code, started taking a bunch of coding classes, a bunch of math classes online, linear algebra, statistics, Python, variety of things. And if you're interested in any of this and aren't already kind of up to speed on this stuff, I can give you all kinds of resources on how to come up to speed. A corollary of all the stuff that I've done is I think I'm a better online educator because I'm now an online student. I'm taking classes through Georgia Tech on Python and actually Java programming right now. So so this is how I came to be interested in this, and I realized I bet a lot of law students or lawyers could benefit from this type of knowledge as well. So we start teaching. I start teaching a class called Coding for Lawyers. It was co-taught with a former student of mine. And his biography is actually an important part of this story as well. He was a student of mine in criminal law. Like me, he was a history major undergraduate. And somehow we struck up a conversation, and he mentioned he had had one computer science class undergrad, which was a slight exaggeration. It was a very, very basic computer science class undergrad. I said, do you want to work on this thing with me? You can become my research assistant and we can play with this. He did. Remarkable human being. This is a guy who actually had one computer science class, very basic level undergrad. We start learning this stuff online, working on these problems together. He really goes gung-ho about it. He gets admitted to a PhD program in computer science at the University of Pittsburgh without having any formal training in it. He self-taught himself to do this stuff and basically tests into a PhD program without any formal training. Brilliant, brilliant guy. He called me one night. Actually texted me one night, one morning. He said, "So I built a program that'll play chess, and I want you to play chess against it. It can't beat a grandmaster, which I'm clearly not, but it can beat anyone up to the ranking of a 1500. And if you're a chess player, you know what that means. That's really, really good." I said, "Man, we got too much work to do. You don't have time to be writing a chess bot." He said, "I couldn't sleep last night, so I wrote it." So like overnight, he writes this thing. So he clearly a brilliant guy, and he's now doing his PhD, working on at the intersection of law and computer science, and the policing project is going to be part of his dissertation. So he and I decided to teach this Coding for Lawyers class, Python, the stuff that runs the programs that we're doing for the policing project. And we also then began teaching a class on statistics and machine learning, and then he's teaching a class this fall at our law school called Natural Language Lawyering, which will show students how to use large language models, actually build things with large language models using Python, using real code. A lot of law schools are doing classes now that they say are either low code or no code. We're absolutely code. And I love David's talk yesterday about math and the importance of like the skill sets you learn from solving problems mathematically. We are very heavy into math. We take people, we absolutely say, we don't want you in taking this class if you've already had this background, you need to be more advanced. But we're going to take you from zero to whatever it is we're getting at the end of this class from where you are, and it's going to be fun. And so I'll talk a little bit more about the math we end up doing when we get to statistics and machine learning. So why do this? Like, why is this valuable? Why am I just like a lawyer who realizes he should have gone to computer science school as an undergrad? Maybe. But the bigger thing is, if you look at where our profession is going, if you look at how everything is becoming automated, the potential of these devices to totally upend our profession in good and bad ways is extraordinary. I've heard it said that robots are not going to replace lawyers, but lawyers who understand AI will absolutely replace lawyers who don't. And I think that couldn't be any more true. And my view is that if you teach folks not how to use devices other people have come up with, but if you teach folks under the hood how to build things from scratch, then they can not only adapt to things that other people have built, but they can build their own things. And we've actually seen our students start to do that. So our first class, coding for lawyers. This is essentially an undergraduate level class in Python. And Python is programming language. I think 46% of all programmers now use this language. It's very popular because it's probably the most intuitive of all the programming languages that are out there now. Our class starts just like any other old undergraduate class would do. You start off, the very first code we have them write is print hello world. Why do we do this? Because we want the shared experience. Every single computer science class begins with print hello world. We don't want ours to be any different. We want folks to actually have had that same common bonding experience. And then we take them through various things like iterations, loops, and data structures. So you have an example there of a list, and we show how lists work in Python. And then we start to mix it up a bit. Before we actually get into the law, we start to have a little bit of fun. We found fun data sets. So we found all the data from the Kentucky Derby, the Preakness, and the Belmont Stakes, like jockey weight, speed of the track, the weather circumstances that day, and we have them manipulate that in a database. So if we have them all put this mass amount of data, not mass by computer science terms, but too much for one human being to read. All this data from all three races, and we say, what were the track conditions in 1852? Actually, sorry, 1892. They don't start until the 70s. So 1892, what were the track conditions at Churchill Downs? So you could then query that and pull that up from this database that they build using lists and dictionaries and various data structures from Python. And then we start to introduce legal applications. So this one is a really cool one. My co-teacher, Morgan Gray, particularly loves regular expressions. We had this little fight because I thought his regular expressions lecture was a little unclear. And my wife heard it on the phone, and she said, is this something bigger between the two of you? I said, no. Morgan just really, really cares about his regular expressions, and he does. He does this class, and he does it remarkably well. What a regular expression does is it creates a pattern, and it says, go search through that text and find me every example of something that fits that pattern. So you see the R quotation mark. We want three numbers in succession: 0 through 9, 0 through 9, 0 through 9, and then with a space, U period. And then that period between the brackets designates a space or a lack of space, and then S, and then the same thing at the back end. This one will only find for you in those opinions U.S. Supreme Court citations that have three numbers before the S and three numbers afterwards. And obviously, you can modify the regular expression to find numbers from 1 digit up to 4, or however many you want to do on both ends of this. But we take them through that, and we show them how these regular expressions work. This is obviously not sort of large language model kind of thing. This is actually a precursor to what people were doing with large language models. With this, you're saying, go find me things that look like this. And there are many times when you are wanting to use computer science to go through a vast amount of textual data, in which this kind of a basic regular expression device is preferable to a large language model because it's entirely predictable. A large language model, you don't know exactly how it's working, and it'll hallucinate, it'll miss things. This will get you everything that fits that pattern. Now, that's going to miss some things that are like this. It's going to miss sort of the analogies that large language models will get you. But knowing how this works, and if you know things that fit very precise patterns, don't ask a large language model to go out and look for things that kind of look like this if you know exactly what you're looking for. So we teach them this, and obviously we eventually get them to working with large language models. but we teach them the basic core stuff that came before this. We teach them the foundation, and the hope is that with their legal knowledge and with their now computer science knowledge, they will think about new applications. So the second course we started to teach, statistics and machine learning for lawyers. When we get to some stuff later that we're working on, I have a big sign on that says under construction. This is also under construction because we taught it this year in R. And if for anyone's ever used R and Python, Python is far more intuitive. I literally was building this plane as I was flying it. I learned enough about it to teach it, and I really wanted to get this into the law school curriculum because I feel like, I mean, my view is if folks don't know this stuff in 5 years, they may not be competitive for a lot of jobs. The world is moving that fast, so I wanted to get this thing going. We're going to do this class again next year, but I'm going to flip it all over into Python and have them actually build more of the statistical models from scratch in Python rather than using R, and that'll actually in many ways be more intuitive. But we designed this with R, and I'm going to walk you through the projects the students worked on, and kind of how we did the class. So this is, they were working with data that looked like this. Big data. The project that I had the class work on as a whole was policing data from Vancouver for 20 years. There's this wonderful data site called Kaggle that has all sorts of free accessible mass data. It looked at all the arrests in Vancouver for 20 years. We built a predictive policing model. And I know many of you in the room are sitting there wincing right now when I say predictive policing because you know about biases and that sort of thing. And that was precisely the point. I wanted to teach them how to build these models, and I wanted to teach them as they were building them how to look for biases. A lot of people talk about algorithmic bias that don't understand algorithms. I want them to understand algorithmic bias from first understanding the algorithm and then seeing as part of it how bias will creep into the system. So this is actually a data set from one of the final group projects. This one I think is drug overdoses during COVID. Let's see. So what we start them doing with these projects, and this was something I was very conscious about doing. I wanted it to be fun for them from the start, even though it was going to be very hard conceptually to get some of these topics. I wanted them to see progress. I wanted them to see, wow, I can really do something. Like I took a class on the bluegrass instrument, the dobro, and my teacher for like weeks was showing me scales, and I was completely bored. He showed me the first tune to play, and I was captivated. I ended up giving up the instrument, but I was captivated when I could play my first song. I wanted them early on to start off playing a song. So we started off with mapping data. I said, now that's your big snap. That's playing a song the first time you play an instrument. That little code there, it's a little bit longer. The whole thing's a little bit longer than that. But we take what was on this previous slide, and we flip it into that, just with a very little bit of code so you can visually represent this. We created an API. We got an API key that linked us into Google Maps. We got them all signed up for this. And boom, that's what they produced their first week of class. I wanted them to be captivated by just the beauty of what you could create and just the ease of this before we got into more complicated stuff. And then we started doing kind of the basic stuff that you'd expect. We taught them how to graph like various different types of crime, pie chart, bar chart, et cetera, et cetera. And then we got into building predictive policing models and did so with the graphics that they had integrated in. So on the left-hand side of the screen, you see a 2D model of what the device we built, where we predicted in this little community of Arbutus Ridge in Vancouver, where burglaries were more likely to occur than other areas. And so what we did with this was I showed it to them in the 2D model, and I said, so look, what's the usefulness of a predictive policing model if you could just look at historic crime patterns on a map and go, huh, here's where we've had more crime. Well, that just looks purely at the number of crimes that have occurred in the past and puts it on a map. Concentration. Okay, easy enough. Then we move to the model on the right, which they built this one from scratch. So then they were able to integrate things like this into their own models that they built from scratch. What the model on the right does is it shows you how, like a police officer or a police department could look at the model on the left and go, huh, there are more dots in the south of this community, and there's a spot in the north. We'll send more patrol cars out there, and that'll be helpful. And if you were only looking at pure numbers of crimes and locations, then great, sure, that's wonderful. But then when we start to introduce more elements, they become harder to visually represent. So the map on the left looks solely at two independent variables, longitude and latitude. That's it, and that's what gets you. That's what gets you that first model, that first image on the left. On the right, we've now introduced to the model time of day. So if you look at the z-axis, the one that's going straight up and down the screen, that's the hour of the day. And I'd say it's actually possible, and in the model allows us to spin that around. I said it's actually possible to look at this and get some sense of it. But now let's say that we're going to introduce new variables like temperature. Temperature actually does determine the amount of crime. Rainy or not, weather conditions. These actually do determine crime levels. So once you start to do that, then you're talking about 4, 5, and 6-dimensional space. That's not something that you could just represent on a map and hand to a police department or an officer and say, there you go, predict on the basis of that. So we then see what the value of an actual model is as opposed to just a graphical representation of past events. Then I think this is when it gets really fun, because they've heard their entire time prior to taking the class about concerns of biases, particularly with predictive policing models. This is like the most maligned stuff that's out there. So one of my groups, and I didn't know exactly how we were going to get into looking at issues of bias in Vancouver, but a kind of a beautiful thing happened. What their homeworks were, so we've looked at, Arbutus Ridge and burglary, go predict something else. So one of my groups of students wanted to predict where assaults would occur, because her theory was, I bet you the assaults are going to occur near bars around closing time. Pretty logical assumption, but you want to see if it's correct. So she starts to work with the data, and she goes, wait a minute, this one community seems to have no assaults. And so then she starts to play around some more, because we would do office hours in class, or we would do kind of work time in class for them to play with these things. And she said, wait a second, there were no assaults in this community. She started to play, or that one, around these times. I said, how is that possible? And then we realized something kind of quirky. It turns out that for burglary in Vancouver, the hour and the minute are recorded quite precisely. For assaults, they're only recorded by the day. So what's fascinating about this is actually the city of Vancouver, as well as a couple of other Canadian cities, are actually using predictive policing models. And one of them that they use, predicts the incidence of burglary in the locations. They don't predict anything else. And we discovered why. Because you only have crime by the hour data for burglaries. You don't have it for assaults and homicides. And there's so few homicides in Vancouver, it's really hard to predict those. But for assaults, there certainly are enough of them to predict. But they're not recorded by the hour. So the city of Vancouver has built a model for burglary, and they have deployed police officers on the basis of this model, and they have had great success in bringing down burglaries. What we don't know is what happened to assaults during that time. And we didn't run the numbers. We could have run the numbers. But what we know is that what the Vancouver police have done is that they have deployed police to address a problem that the data allows them to solve. There's your bias, right? We're trying to solve the thing that we know about, burglaries. So we deploy on the basis of where we can now quite accurately predict burglaries are going to be. But that's going to divert resources from where the assaults might be. And now you understand the limits of data. And now when they go in and talk about algorithmic bias, because they've built the algorithms, they've played with the data, they can now say, oh, wait a minute, we need to look for this, that, and the other. And it gives them a sense of problem solving. And this is David's talk from yesterday. Understanding math is about understanding problems. We talk all the time as lawyers about discrimination and bias, but you need to know how to actually look for it. And when algorithmic bias is at issue, you need to understand how that bias hides itself in machines or data, so that you can begin to examine it, understand it. Maybe you're able to correct for it. Maybe by better collection of data, maybe by better use of the data, you can still use these things. As one of the speakers yesterday said, actually it's David, all models are wrong, but some models are useful. Maybe you can build a useful model that will not be infected with this sort of bias in the same way that this one is, in that you are correcting for one thing, but not considering how that affects, actually, I would say, more serious crimes. All right. So then what did our students do with this? They did these assignments for our class, and much like with the coding class, there would be an assignment after every single class, and I held copious office hours. I got a giant screen TV for my office that students could come and plug in, and we would work on their codes there. And I gave them crazy amounts of help. There was no reason to get a bad grade on any of the homework because I would walk you through all of it. And so they did a homework for every single class. And then there were projects that they did on their own and as a group. And I told them to look for a data set that interests you. Or you can even use this Vancouver one. I was kind of happy and sad that no one wanted to do further explanations for the Vancouver set. They all looked at data from Pennsylvania, which is where our law school is. There's this wonderful website called Open Data PA, which has all kinds of data sets from various aspects of public policy concerns in Pennsylvania. And then there's this police data portal from Pittsburgh. And with that one of our groups looked at the history of arrests in Pittsburgh and started to notice some patterns. And I'll show you our next slide. This was from one of our students. One of the really neat things, if you haven't looked into this for your law students, is a publication called Medium. Medium to me is like a really, really intelligent Facebook. Anyone can basically post there, but they post it in a way that looks like a small law review article without footnotes. It really is. It's a great, and I go to Medium all the time. They do really, really good stuff with coding issues. They also do like history, politics, et cetera, but they do a really, really good job with coding issues. So my students are now posting the novel coding solutions they have found, and this one is one that this is how the code in the black there is an R code for how to create that contour map of concentrations or numbers of arrest per area in the Pittsburgh region. So what's next? We're offering this fall a class on natural language lawyering, being offered by my brilliant colleague Morgan Gray, who is going to teach students how to actually work with large language models, to build things using large language models. And then and then within the traditional law school curriculum, we're hoping to expand what we do. Kate will tell you more about what we're doing with the clinic, but we are hoping to introduce aspects of coding into first-year legal research and writing. The current thing that we're working on is having students create a chat bot for folks who have to solve legal questions in a retail way. A group in Pittsburgh that does civil litigation or civil practice for kind of civil Gideon. They do landlord-tenant issues, and they have kind of a hotline for lawyers. The problem is that a lot of the lawyers they get who come in and are willing to do these hotlines aren't sort of following the script that they're supposed to follow for working with people on the phone that they've never met through their claims. And they asked, I said, is there anything technologically we could do? Absolutely. I said, let's build you a chatbot. And a lot of folks don't yet know what chatbots are. You give this device information, and it's much like the airlines. You ask, I've been diverted from my flight. I'm currently in Detroit. Can you get me another ticket? And the device itself figures out ways based on the data to solve your problem. So we offered to create a chatbot for them, for their frontline lawyers who are doing these hotline calls, with no real background in any particular person's case. So there are a whole lot of people who will need chatbots like this, or need devices like this. If you represent an insurance company, you've got to deploy the law for all of your insurance claims settlement folks. So we are going to build into LRW a chatbot exercise where you build a device that will help people who need to know the law on the front line, kind of like what we're doing with the device we're deploying or hoping to deploy with the police. Future modules, completely up in the air. We really are hoping to include aspects of even true hard coding. Just give them a taste of what this stuff is like. And as we learned in our talk, in one of the talks yesterday, there is you can now download the entire corpus of the Harvard Case Law Project. We want to get them involved in actually coding coding to automatically extract research from the Harvard Case Law Project. So I'm going to now turn it over to Kate, and she's going to talk to you about how we're taking this stuff we're doing in the doctrinal, the quote unquote doctrinal, I guess it's doctrinal when you're teaching computer science to lawyers, and putting that into the clinic. And there you are.
Great. Hello, everyone. I'm not going to wander quite as much, but I will be wandering up here. So as Wes said, I'm Kate Norton. I am the director of our clinical program at Duquesne Kline. And to give you kind of the background of my story, I run our family law clinic as well. And I practiced family law for years before I came to academia. And the one thing I will tell you is I learned how to do, I'm not afraid of math. When you start as a young associate in a family law firm, particularly in Western Pennsylvania, you are required to know how to do taxes by hand, family support calculations. So I'm not afraid of math, but what you'll notice is I'm not saying I'm a coder. I've never taken a computer science class. I've never done any of that. I theoretically will be trying to learn it this summer. Wes says I can do it, so I will give it a go, but I am not. But I am very interested in what it can do, because clinics have particular income guidelines. So when we do our clinical program, most of our clinics, you have to meet a certain threshold, meaning you have to be within 187.5% of the poverty guidelines in order to qualify for our services. And my students see firsthand the access to justice related issues that occur. The justice gap, which some of you may know about, is something put out by Legal Services Corporation every few years about the statistics involving what low-income Americans face when trying to access civil legal services. And one thing to note about this report that comes out every few years is it's only based on the data that they receive from the individuals that they fund. There's there's significant underreporting. But in 2021, 74% of low-income households had at least one civil legal issue that year directly related to significant issues that impact our daily lives: family law, employment, housing, benefits, healthcare. And 92% of those households reported that they don't have enough or any legal help whatsoever to address these. Of the 1.9 million individuals who sought assistance from these organizations, only 1 of 2 received assistance. So a lot of the not enough is why? Why is that happening? There's limitations on the type of services, the service models. I think everyone knows the statistics about what a public defender faces, how many cases that they have to work on and manage at any given time. So there's pretty significant limitations on what we can do in kind of the civil legal services world. And as our students work on this stuff, they try to figure out, well, how can we solve this? In our family law clinic, we are a limited legal service model, which means we provide advice, brief services. We help people get from point A to point B, but we do not provide full representation. And because we want to help as many people as we can. And a lot of time we see the various hurdles that folks come in with and why they're having such a hard time. One of the first things we noticed is the bandwidth an individual has to address their legal needs. They're more focused on, can they put food on the table at night? Do they have shelter? Are they providing for their family? The legal issue is almost ancillary to their daily life, but it's very significant. The view of the issue, especially in family law, they view it as a personal issue. We're not going to go out into the world and get help. The substantive law. They don't understand the legal nuances, the law itself, what it means to file for child custody, what the standards are, things like that. There's procedural hurdles. The courthouse is not exactly a fun place. The paperwork, they'll kill you with paper cuts with all the paperwork you have to file. There's mundane aspects of litigation, where to sit, how to even get into the courthouse. Are you allowed to bring your keys in? And then also the cost. And I'm not just talking about the cost of hiring a lawyer, the filing fees, although it is $350 to file a custody complaint in Allegheny County. Who's complaining? But the transportation costs, the parking costs, childcare, what it means to miss work, and all of the associated costs with it. So a lot of times my students are sitting there thinking, well, how can we get our clients? Because they're always surprised every year that our clients aren't exactly happy to talk to us. They don't understand why, like, we're giving them free legal help. Why aren't they calling us back? Why don't they want to handle this problem? They haven't seen their kids in 3 months, but don't they want to see their kids? And so they want to try to problem solve to make the process a little bit easier to them, which is how we got to the potential of an AI and tech solution. So there's a lot of pros to this, and it helps the hurdles. One, the availability, the ease of use. What my students were thinking about is like, look, isn't this great? They can use it on their computer at home. They can call us whenever they want. It's more accessible to them because it's not between that, 9 to 5 hours of the courthouse. Depending on when you get there, sometimes it's only 9 to 10 on who's there, who will answer your questions. It also combines a lot of the existing service models in legal services. You can self-help materials. That's the primary source for low-income individuals. It's, a website that they can go to and read about how to file their paperwork. Or I use this example at another talk I was giving one time, like, divorce for dummies. Although no one in the room knew what that was because I had clearly dated myself. But those self-help materials. It also can be limited legal services. This is one of the most popular forms. It's the one that we provide in our family law clinic that really takes kind of giving that limited advice and helping prepare that documentation to get over those hurdles of like understanding the legal aspects. And so all of these things combined with an AI and technology solution can help overcome a lot of those hurdles we just talked about. However, there are some negatives to it. A lot of the work that we see, although it's really been great being here because we've talked about the other aspects of it, is currently focused in the for-profit field, discovery, tech tools, things like that for the big, large law firms. There is a digital divide. I think my students are often surprised when we have clients call, particularly grandparents in custody actions, who don't have an email address, or they still use their home phone, or they have a cell phone, but they don't exactly know how to use it. So there is a digital divide aspect. We always get the questions, the ethical issues. Is it the unauthorized practice of law? So how do we address that? And then the concept of, once you have this program, all these wonderful programs we talked about teaching our students, who's going to update it and maintain it? That's a lot of the times when we talk about it, the pushback I get from our bar. And then corrections that need to be made, as well as it is a deviation from traditional practice. I think there was some statistic out there that said like lawyers were one of the last to adopt fax machines. So we're not really a great profession for adapting new technology. And oh yeah, that word math that we talked about this weekend is a little bit scary to some lawyers. So the solution, law schools and future lawyers. So we brought it into the clinic, particularly starting with our family law clinic, because a lot of the stuff that we can do with what Wes is doing in these we'll call them doctrinal classes, although I think they're probably experiential, is this concept of what they are doing to learn the skills first place. They're doing client interviewing, they're doing client counseling, issue spotting, problem solving. They also know the procedural and substantive law, at least by the time I'm done with them, they should. And they can identify these access issues, the kind of cons of using the technology as well. And we did have an existing opportunity with a pro bono program that was completely underutilized. So our first project that we've done is creating a application for our family law clinic to deal with appeals. In Pennsylvania, child custody appeals or any appeal dealing with a child in a family-related issue, such as protection from abuse, they are fast-tracked. They are very procedurally difficult. You have to get a fee waiver. Their timing deadlines are shorter because they deal with children. Instead of the traditional 45 days you have to file, you only get 30. Then you have only so many days to file your subsequent documentation. There are very strict formatting requirements. I mean, our courts are even down to what font size you have to write in, which is really fun. I call it clown font because it's like 14 or 16 font. There's waiver risks. If you raise too many issues on your appeal, it's waived. If you raise too few, it's waived. So it's all over the place. And the legal standard is an abuse of discretion, error of law, best interest of the child. It's very hard to object to what a judge did, and it's very difficult to express why the appellate court should even care. A lot of these cases in Pennsylvania, best interest standard, it's 16 factors, and it can be, it's not specific. This one doesn't mean more than the other one, and so on and so forth. So this pre-existing pro bono program was a limited legal service where our appellate court actually got a number of folks interested in volunteers years ago, like 2011. And it would help individuals who were under 125% of the poverty guidelines file their child custody action or their protection from abuse action appeal. It was very difficult because in order to qualify for this program, you had to have a copy of your final order. You had to provide a whole slew of demographic information to the intake individual who reviewed it. You had to give a brief description of the error of law or abuse of discretion. Unfortunately, a lot of folks, when they would do these, would say, judge didn't like me. Judge wouldn't hear my side of the story. Judge wouldn't look at, if they were sophisticated, my evidence. They don't know my child, I do. Nothing that would necessarily raise an issue for a legal standard. And these were then screened by volunteer attorneys for merit. When I say merit, it's a little bit of kind of a hiding the ball, because when they say merit for this pro bono program, they mean something that it has at least a shot of being overturned on appeal. They don't mean actually just filing the appeal, because generally speaking, you can file an appeal to any child custody action. They have to take it, they'll review it. But what they really mean is something that they think has a chance of success, that has a final order, that's timely. And then if you meet all of these standards and you've explained it on your handwritten piece of paper that you turn in, then you will get a volunteer attorney assigned who will then draft the brief and argue it in front of our appellate court. So the problem with this program, why it was so underutilized, is you have to provide all your financial information. Our standards are set in our rules of civil procedure. It includes things like stocks, bonds, things that our clients don't have, nor do they know what they are necessarily. It has to be timely within that very limited time frame. And for the program to actually be accepted into this pro bono program, you have to do it in such a way that you can get to an attorney to still be able to file within that 30-day time frame. And a lot of our clients don't even have time to digest the order that they receive to then even qualify for this program. It must be final, which seems pretty simple. Order of court, it's entered, it should be easy to figure out. Not necessarily, because a lot of custody cases have interim orders, and so understanding that it's final. And then since we only have a limited pool of attorneys who are willing to do this, they have to be able to take it on, and they have to do it within a time frame that it fits their schedule. So because of this, and with litigants having difficulties expressing their issue, we didn't see a lot of traffic through this program. And there was another problem that if somebody did file and was accepted in this program, hopefully it had a chance of success, because once it was filed, absent enforcement of that underlying order, everything at the trial court is done. You have to wait for the appeal to finish. So super underutilized program. So we're like, okay, we know technology is an option. We know our students are starting to learn how to code, because this was being done simultaneously with the first time coding for lawyers was offered. And we were able to secure an American Bar Endowment grant to actually hire a consultant to help build the program itself, but then we use the students as well in the process. The program itself was a basic expert system, and it would go through the various things: financial eligibility. It would do 3 distinct tasks: determine whether or not an appealable order it was there, so final time frame was within the right time frame, whether or not they were financially eligible, and then it would automatically draft the fee waiver and tell you this isn't a moot case, this is a final order, which was great because the students who would then deploy this program when they interviewed a client would be able to tell the client very quickly that you don't qualify for this program, let's look for other options. Or if they did, moving it forward. It would also determine legal issues to write their concise statement of errors, because that concise statement in a child's fast track case has to be filed at the same time. So it would help the students through the program kind of walk through with the clients, what kind of errors occurred. And then it would draft the concise statement and the notice of appeal, all the required filing documents. And it didn't have to be complicated. This wasn't a super complicated system. Again, I understand this stuff and I'm not a coder and I don't know how to do it, but it didn't have to be super complicated to be pretty successful. So here's kind of a look like what the starting of the program looked like. And then it would produce these various documents. And then we could pass it along to the reviewing attorney to ultimately get it taken on. And then here's kind of the standards that it would look like, all the different legal issues that it would walk through from, we consider criminal convictions and custody issues, whether there's enforcement issues, standing, whether or not you even have a right to ask for it, and so on. And so we added, because my class was half of students in Wes's coding class with Wes and Morgan, and half that were not, we utilized the students as this program was being built to run through it, to troubleshoot it. And it enhanced their issue identification. And really, they were a true part of this program. And they started to see different ways that they could use this to help provide further services. So a couple things we noticed after we had the program and it was deployed for a while, and we did get some more people into the program. It was interesting. We found that we filed less appeals because there were better options out there as we started to utilize the program. So one, lawyers were happy. We had more volunteers who were willing to take on cases. We recruited actually some new law firms to participate in the program itself. The students had tons of creative ideas and solutions, and they really did enhance their issue spotting. It also, one thing I noticed about all my clinic students when they walk in the door, they're terrified of going into court, making a mistake. This confirmed their knowledge base, that they knew what they were talking about, and got them into it further. So it was really effective. And it really did help our litigants express their legal issues and identify potential other paths. That was the biggest thing we took away from this, is the students were utilizing the program as they interview clients and giving them kind of other options. Like, okay, I know you said that you think the judge shouldn't have done this, but this is some of the paperwork you should have filed, or this is some of the issues you should have done, because the program really did walk through all of those legal issues. Faster screening process, and it really did help overcome those hurdles to assistance we see, particularly the bandwidth issues. So we've been using this program now since early 2023. We're still using it. Students are troubleshooting it, extending it as we go along. And there was so much interest that we now have kind of new ideas as well. So one thing about the appeals program that was built is it's a transferable model. We can take that model and transfer it to other areas of law, and we hope to kind of expand. We also want to, right now, the program we use, as you might have seen, it's not super pretty. It's not like your, online food ordering app that's really easy to follow. We hope to eventually get it in a format that can be utilized. We can put it on kiosks at a courthouse where it can be utilized by litigants directly. And then students can review the documentation that is the output, because the one thing that's nice about all that pretty documentation, it's real easy as a supervising attorney to take a look and know if all of the I's are dotted and the T's are crossed. And we want to make it accessible to the bench. One thing that we discovered is some of our judges were like, well, if you can do this on the back end, why can't we use it on the front end to make sure we're addressing the issues that we can? I'm not sure how I feel about it, but that is one of the requests that we got. Our students are starting to kind of look at ways to build programs that can be utilized by litigants, particularly low-income litigants. And it does train them in their traditional lawyering skills that we've discovered. It really helps with issue identification, problem solving, helps with client counseling. I've discovered over the years that some of the things we have to do is remind students how to make a phone call because they're so used to texting and emailing. So it does help with that as well. And it does provide access to the courts. So we want to keep building this. And so here's what we've got planned. It's not done yet. We're in the initial processes. Actually, Wes and I, when we get back, have a lot of work to do. But we are going to start an externship with our clinical program. So we have externships all over the place, and we're going to bring our externship kind of in-house for our clinical program so that our students who know this coding, who have taken these classes, can build kind of these programs for partners within our community. And all sorts of things. Wes mentioned the chatbot that's a partnership with Neighborhood Legal Services. We're thinking about doing statistic tracking for protection from abuse cases. The court has asked, is there any way that we can start to get this data? Because they do have such a hard time with keeping, not keeping track of the cases, but with the data that comes out of it. Are they actually assisting people? Is there a better way to handle these protection from abuse cases? And then the big thing that we're going to try to do this next year is our juvenile court with our dependency cases where children are deemed dependent upon the state are a call of the list, and they don't get handled in a timely fashion. The kids can be sitting in the courthouse for hours, the probation officers, all sorts of individuals involved in the system aren't necessarily getting to where they need to be. So things are getting continued and continued and continued. So we hope to potentially help with a court scheduler. And because coding for lawyers is now taught every year in our fall, we also hope to bring they do a year-end project every year. And one of the students, actually in the very first one, did create an income verification program for the clinic in 2022 that we can use to help qualify our clients for our programs themselves. But we also want to expand that. We want to give students the opportunity that, hey, if you're stuck with an idea, how about this? We could use an intake process, one that gets all of the information that we need to give to our grant providers, or a resource program. We get a lot of people who call that we can't assist. So is there a program you can build that whoever's answering the phone that can type in a few things and then get all the various resources for individuals? So we've taken what we've done in the doctrinal courses, quote unquote, and now we're taking it into the clinical program to kind of give the students the experience to build and then see the results. So I think that's it. Did I cover everything, Wes? All right. So next up, questions, if we have any.
I think this is probably more for Wes. Do students need any special computers or equipment?
No, that's actually a great question, because we tried to figure out like what interface to use for them. Because if you've ever done any programming at all, you know that like this stuff, sort of the barriers to entry just before you could type the first print statement are pretty high. And so we didn't want to have to upload a bunch of stuff into their computers, because like sometimes that will be inconsistent with something that's currently running their program. You'll have to troubleshoot. When I started talking, there's like 7 other people who teach this class in the country now. And when I started, there were 3. So I talked to all 3 of them. And the one thing they all said is kind of your question. The big issue is troubleshooting. There'll be all these various issues. And it turns out that for the Python class, it's actually very easy, because Google has something called Colab. Just like how you go open Google Drive and other things, Google has a platform in which you can code Python that has Python right there. You don't have to do anything. And so no, you're actually not, you're only using your computer to then link into Google. And so no, they don't need anything special at all. Now for the R class, it's more complicated. But that's one of the reasons we're shifting away from R in the data class, and going back to Python, because Python is just easier on a whole lot of levels.
Yeah, and it was actually because it was collab, the students were then, when we were troubleshooting the code for the appellate program, able to log in from their individual laptops, fix the errors that were occurring, because we had a couple loops, they were able to fix those and then just kind of move right on.
Mhm.
The one thing with computers, though, is when you're doing it for the clinical aspect, we do have one computer that can be utilized by students to the extent that we have to save any data. Because that was one thing we were concerned about, was leaving, a lot of the demographic information that we get is pretty sensitive. So we wanted it in-house, that if we needed to, we could delete it, shred it, or at least it was on our individual mainframe and server.
Yeah.
This is an undergraduate. This is an undergraduate course.
No, it's a law school class.
It's a lot. And how many law students are signing up for?
Oh, great question. So, I'm going to answer that. And another question I typically get, I often get the question, is your faculty on board with this? Because we've heard a lot of people at this conference talk about how the faculty is not really all that receptive to the ideas of technology and teaching. We have had, I would say, a very warm reception at our law school, and it's because of the answer to your question. The very first time we offered this, we had 80 people sign up. And we've got a pretty small class. We have about 150 people in each, like first, second, third year. So 450 people totally, 300 of whom would be eligible to take the class because they're second or third years. And we had 80 people the first year sign up. Now, when I finished the story, when the syllabus came out, it went down to 68. And then after the first week, it went down to 57. But we had 57 people complete the class. The second time we offered it, we had 30. And then for the statistics and machine learning, which admittedly has a scary title, we had 11. But what was interesting about the 11 is, like, with the exception of 2 people in that class, I would say that 9 of them are now capable of doing extraordinarily sophisticated work. And then the thing I want to offer then at the end, in terms of like what next, in terms of like the scope of all this, I spoke at the PyCon convention, a convention of Python programmers, and we met with some folks from Bloomberg, and I said, we want to place our students who have these tech skills in legal tech companies, and they said, absolutely. We had no idea any law school was doing this, and if you can get them to have a class on data structures and algorithms in addition to what you're teaching, we'll absolutely hire them as programmers to code the law for what we're doing with Bloomberg Law. There's a whole new set of professions out there. And Bloomberg, obviously LexisNexis and Thomson Reuters. Thomson Reuters is going gangbusters right now. Bloomberg hopes to become the Google of law. So there's a whole range of opportunities for jobs for students with these skills that just didn't exist before and no one really thought about. So one of my students who took the coding class last year, did the machine learning class with me this year, he took data structures and algorithms in the college. I was a little bit nervous because I kind of pushed him to take it, but like his only formal training was with me. And I was kind of nervous how he would do in the computer science department. And he got an A-. And I tell you, there are it's like you look back on your career, I've been doing this for over 20 years. This is the most fun thing I've done. And this has been the most personally rewarding. My student Morgan goes on to the PhD program. This student takes data structures and algorithms in the computer science department and does really, really well. This is so much fun to watch. And so, yeah, if for those of you who are not into this or have some background, no background, get into it. It will totally change. You become a new discoverer of information. Like after you've been teaching law for a while, you're kind of making like incremental moves. You're learning a little bit of this, a little bit of that, a little bit of adding on to what you already knew. This was like a total paradigm shift for me, and truly the most successful, most personally rewarding thing I've done in my career.
Yeah, and one thing to add, kind of the shift of why we saw so many, I think the first time it was offered and then kind of died down the next time it was offered, was because, so we've been working with student groups to talk about generative AI. ChatGPT scared them, I think. They had so many bad experience in undergrad where it was, if you even touch this, you're cheating. So a lot of them are actually afraid of it now. So it's now we're changing, which I was shocked to hear. We had a meeting with the students like, well, no, you don't understand. We're afraid to touch this stuff. And we're afraid to utilize it because is it the unauthorized practice of law? Is some judge going to call me out for using any form of, AI in a courtroom? So I think we're battling a little bit of that now. So that's why the one thing too is by bringing more of the clinical programs and showing them like, no, a lot of my students get really, family division is like changes with the winds in our current county. So getting them to see the practical application of the work that they're doing and how it can help, I think has been helpful too.
And I also think one of the things that is going on is we're going to get a smaller core of people who are really, really committed to this, because it does take a certain type of willingness to experiment with new things. And so I think we're going to start graduating a very small core of people who have crazy cool tech skills. All right. Well, hey, thanks for more.
And so give us an example of what they will be doing with this when they get out of law school and they join a law firm.
Yeah. So, I mean, obviously, like, e-discovery, they'll understand e-discovery like nobody's business. One of the things that, I think a great example of something that they'll do is build expert systems, and actually more complicated than expert systems, things that rely on large language models, et cetera, that will actually involve client counseling. And we've seen that already more in the UK than the US. So let's say that you represent an insurance company, and your insurance company has got to settle claims, and you've got to settle a whole bunch of claims. You can't you can't call a lawyer every time you want to, every time you have someone who has a house fire. And so I think that lawyers in big firms will be building these systems for clients who have mass amounts of times where they have to solve, the client has to resolve a legal issue. I think the insurance industry is just a great example of that. In the pro bono space, there's all kinds of stuff that's underdeveloped, just like what we were talking about.
And I think too, a lot of our students, they don't just, we have a lot of mid-sized to small law firms that our folks go to. So I think we'll see a lot of work there where they'll utilize their knowledge to kind of build these to help with an intake process, to help kind of do that initial screening to make it more efficient as well.
Yeah.
You mentioned that you're teaching both Python and R.
Yeah.
Is if a student were to develop proficiency in simply Python,
yeah,
useful?
Absolutely. And in fact, I'm going to flip the R class and go Python class. And honestly, I was learning this stuff so fast that I thought that R was the better system. And some people say it is the better system for machine learning. A lot of people who do it will say that. But I've come to learn that Python is actually mostly every bit as good, and it's far more accessible. So I'm going to just be teaching in Python because we won't have to retrain them on a new computer language. And, Python, 40-some% of all the programmers are using that. So I think Python is as close to English as a universal language as it's getting right now. So I absolutely think Python sufficiency is enough. All right. Well, thank you all so much. Appreciate you coming.